good day to all. Today our topic is genetic algorithm. Myself, Dr. B. Suresh Kumar, Department of Mechanical Engineering. Nowadays, artificial intelligence playing vital in engineering industries. Artificial intelligence always inspiring the human intelligence. Okay, in that there are a lot of subfields are available. The subfields are planning, natural language processing, speech processing, machine learning, engineering and expert systems, fuzzy controls, models of brain and evolutionary, machine vision and robotics. That today we discuss about models of brain and evolutionary technique. Models of brain and evolutionary technique has subfield. That subfield is named as genetic algorithm. Genetic algorithm always mimics the natural selection process. GA is also one of the non-traditional optimization techniques in engineering industries for making a decision. It follows two steps. One is population of the points are involved. Second step is probabilistic in nature. The probabilistic in nature follows two steps. One is a random number generation, another one is natural behavior following. What is the natural behavior? Generally, we need a baby means the combination of a male chromosome and female chromosome are responsible factor. But how can we get the best child? The best child we can get through three operators. The three operators are reproduction, crossover, mutation. The GA starts with the population of strings, thereafter generates a successive population of strings with three operators in many practical problems. Generally, the genetic algorithm starts with the flips, coin flips. For example, if you toss the coin, we may get the head or tail. For example, we get the head means we assign the variable 1. If we get the 0 means we put the numerical variable is 0. So that 1 and 0 combination reversibly we make it through coin flip. For example, in this bottom of slide, there is 0 1 1 0 1. After that, second one is 1 1 0 0 0. Likewise, we may get the number. These numbers are known as strings. These strings develop based on the coin flips. Okay, after getting these strings, we may go for operator calculations. Operator calculations are reproduction, crossover, and mutation. In that, first we will see about what is the theoretical concept available with the reproduction. Reproduction is the concept of worst is replaced by best one. After that, second operator is crossover. Crossover means new populations are generated from reproduction operator. Yeah, the crossover has two steps. One is first one is a random number generation. Second one is a pair of strings crossing with each other. With example, I will explain. The example is there are two strings. The first string is named as A1. The second string is named as A2. Through the coin flips, I may get 0 1 1 0 1 as a A1 string. Through the coin, another coin flip, I may another set of coin flip, I may get 1 1 0 0 0, which is known as A2. How do I conduct the crossover? Means first I get the random number from Monte Carlo method. For example, if I consider this A1 and A2 as a example means I may get 4 as a random number. From A1, I have five digits. From that, because of four random number, I select first four digit. After four digit, I may put the straight line. In after line, I may get the one. Likewise, A2 after line, I may get the zero. I interchange the one and zero with each other. With each other means A1 and A2. From that, I may get A1 is equal to 0 1 1 0 0. A2 is equal to 1 1 0 0 1. Likewise, I may get the new strings after crossover. Each step is known as crossover. So the crossover and the reproduction always follows the random number generation. Finally, Final operator is mutation. Mutation means locally and hopefully tested. Reproduction and crossover effectively search. Also, the mutation is needed for avoiding of loss useful genetic material, that is 1 and 0. Mutation means, for example, if you are consider the bottom example of this slide, there is the string values 0, 1, 1, 0, 0 is available. I After that I generate a random number. The random number is 4 means I put the square and choose the 0. Okay, fourth digit as a 0. I convert that 0 it into 1, which is the mutation process. So that I convert where the 0 or 1 available, and I convert that 0 into 1 or 1 into 0, which is the step of mutation. Okay, okay, these are all the theoretical concepts available with the three operators such as reproduction, crossover, and mutation. Okay, these are all the things available with the genetic algorithm theory. Okay, now how do we solve the genetic algorithm manually? This is the next biggest question. In each and every problem solving, initial step is we should have the problem, so that our problem is maximize z is equal to 2x1 plus x2 power 4 subject to 0 less than or equal to x2, x1 and x2 less than or equal to 9, which is the problem, which means z here, z is the objective function. We should maximize that objective function with mathematical formulation of 2x1 plus x2 power 4. Here x1, x2 are the variables. Okay, x1, x2 are the variables. These are all subject, the lower bound value is 0, maximum value is 9. In genetic algorithm, we should assume before starting the problem. So here bit length. You should aware about this problem. What is bit length? Bit length is equal to even number, generally even number is equal to 8 to 10. Crossover probability 0.5 to 1. Mutation probability 0.01 to zero point 0.1. Number of population is equal to 10. Number of generation is equal to 1. Some things you may aware about after completing this problem. Here to find x1 and x2. What is x1 and x2? The newer point from older point. X1 is equal to x1 minimum plus x1 max minus x1 min divided by 2 power L minus 1 into random number 1. X2 is equal to x2 min is equal to plus x2 max minus x2 min divided by 2 power L minus 1 into random number 2. These are all the formulas which are all helpful to finding the x1 and x2 values. Here the solution accuracy, how much of our problem has solution means solution accuracy is equal to x1 min plus x1 max minus x1 min divided by 2 power L minus 1 is equal to 0 plus 9 minus 0 divided by 2 power 8 minus 1 is equal to 9 divided by 255 is equal to 0.03529. Likewise, I calculate manually. What is here x1 max and x1 min? According to our boundary, there is parameters 0 less than or equal to x1 comma x2 less than or equal to 9. So here x1 min I put 0, x1 max I put 9. From that L is the bit length value. For example, in my problem I consider L is equal to 8, so that 2 power 8 minus 1 which is 255. 9 divided by 255 I got, so that our problem solution accuracy is 0.03529. Okay, fitness function. What is fitness function? Our objective function is the fitness function. F is equal to f of capital F is equal to f of x for maximization problem. Capital F is equal to 1 divided by 1 plus f of x for minimization problem. Our objective function is maximized with respect to our profit. The our objective function may be minimized with respect to our production cost associated with uh, the production, so that these kind of objective function or fitness function we may have. Okay, after that example of problem solving by using genetic algorithm. Initial randomized population generate random number 1 to 100. This is the example problem, so that generate random number between 1 to 100. Now after that, convert decimal number to binary number for substring. Wait, you may aware after completing this problem what are all the steps. Okay, so first serial number, after that random number one, after that substring one, random number two, after that substring two. Likewise, you generate the table. After that, you allot the population. You consider population size as 10, so that I generate 10 serial numbers. Okay, After that random number generation, how do I generate the random number? For example, if you are having calculator, you may examine with my example. Okay, how do I generate the random number? For example, if you consider your calculator, there is 100. For example, because I generate the random number in between 1 to 100, so that I put 100. After that, rand hash button was equal to 80.3, 48.4, 13.2, 4.7, 10.1, 32.9, 57.5, 22.9, 27.9. I make it continuously with the equal to symbol on available with the calculator. Likewise, I make it the random number from this calculator action. Now you are aware about how to produce the random number with the calculator. So that according to our calculator operation, I may collect 10 random numbers. So that after random number selection, I may go for converting the substring. According to our initial theoretical description, there is head means 1, tail means 0. Here also I may get a substring like 1 and 0. How do I generate a substring value for 14? For example, if I consider this first mode, press the mode with the calculator, say 2 times, after that 3, you may get a base value. According to my operation, you may have a binary b decimal. You convert that b into d. After that, you may press 55. After that, you may press equal to symbol. Now you press the bin with your calculator. You may get the 6-digit binary number. Likewise, you may change the number also. You can change the number also 69. Convert that into decimal symbol. After that, you may process equal to symbol. After that, getting 69 in display. After that, you may go for binary. Now you may get the 7 digits of binary code. It is the conversion of digits decimal number it into binary number, which is known as substring. So that you convert all 10 random number it into uh, binary numbers, so that I may get random number 1 with respect to my population size 10, and also I convert that random number 1 into so binary value as a substring. Okay, similarly I said choose random number 2, I convert that random number 2 it into binary numbers with respect to your slide display. Okay, which is the first step available with the genetic algorithm. After this, I may go for find x1 and x2. Okay, initiation, population initiation available generated with the random number, because it is a random selection process. After this step, we go for to find x1 and the x2 and f of x. Okay, here x1 formula already I define what is x1, what is x2. X1 is equal to x1 minimum plus x1 max minus x1 minimum divided by 2 power l minus 1 into random number. Okay, here the random number, first random number 14. Okay, what are you aware about? The lower bound is 0, maximum value is 9. So that 0 plus 9 minus 0 divided by 2 power 8 l value, because I consider the 8 bits. For example, if I consider here substring 1, according to substring 1, the 14 value is converted into substring. There are 8 digits 0 0 0 0 1 1 1 1 0. Okay, likewise I convert, so I may put the 8 for L, that is which is bit length. Okay, 0 plus 9 minus 0 divided by 2 power 8 minus 1 into the my first random number is 14. So that I multiplied with the my solution accuracy, I may get the 0.4941. So that initial x1 is 0.4941. Similar to same, I may go for x2. X2 formula is x2 min plus x2 max minus x2 min divided by 2 power l minus 1 into random number 2. The same formula I utilize for x2. Okay, x2 is equal to the same formula. I convert that uh, x2 value. Okay, for serial number, the next step is finding the f of x value, that is fitness function. For getting the fitness function, first we evaluate the f of x value. F of x is equal to 2x1 plus x2 power 4 is equal to 2 into first x1. Okay, first x1 is 0.4941, the x2 value is 0.8118 power 4. According to our fitness function value, f of x is equal to
2 into x1 plus x2 power 4. Based on that, I got the f of x value 1.4225. Okay, this is the maximization problem. So fitness function capital F is equal to f of x. Now you are aware about how do I find out the x1, how do we find out the x2? From the x1 and x2, identify the x1 and x2, we may identify the f of x value. Okay, here I tabulate the x1, x2 and f of x, the tabular column from identified values. I identify x1. Now you are aware about what is x1, what is x2, and also now you go about f of x identification. F, this is the maximization problem. So capital F is equal to f of x. Okay, so that f of x is equal as a fitness function in maximization problem. After that, I summarize. I mean, get the some value of fitness function values. After that, I summing all the fitness function value 1.4225 plus 0.6815 plus up to plus 21.0259, so that I may got to 481.6381. Which is the third, I mean second tabular column. After that, I produce the same population size 10 numbers. After that, I find out the a value. A is equal to F by F bar. Here I don't know about the F bar, but I know about F because F value is 481.6387 from previous slide. What is F bar? F bar is equal to sum of F divided by population size. According to our problem, population size is 10, but summation of F is equal to 481.6387. So F bar is equal to 48.16387 according to this problem. Okay, what is A? Each and every individual fitness function divided by F bar. Okay, so for considering the first serial number, the fitness function is 1.4225. What is F bar? F bar is constant for all the populations 48.16387. So that initial serial number got initial population has 0.0293 as the A value. Similar to same, I produce for all the 10 populations, and then B, identification of B. B is equal to A divided by population size. Population size here in this problem is 10, so that b is equal to a by population size. For serial number 1, b is equal to a is equal to 0.0293 divided by 10, so 0.00293. Similar to same, I produce the b value for all the serial numbers. After that, c is the cumulative value of b. What is cumulative? For example, considering b 0.00293 as the first value, so that I reproduce 0.00293 as the cumulative value of b. For example, if I consider the second serial number 0.00972, how do I identify the cumulative? I add 0.00972 plus 0.00293 is equal to 0.01265 is the second serial number cumulative value. Likewise, I identify all the values. For example, if you are considered for serial number 3, is equal to I sum the other three values 0.00293 plus serial number 2 0.00972. Okay, after that plus 0.02327. Likewise, all numbers I may get the 0.24502 value. Okay, which is the cumulative value. So I can able to find all the cumulative values with respect to population size. After that, d is equal to generate random number between 0 to 1. D is the next column, which is follows the random number generation between 0 to 1. Okay, here I first random number. Now you are aware about how do you generate the random numbers through calculator. Okay, the 10 random numbers I produced. After D, I may go for E. E means I compare D with the C. 0.257 is the first random number available with the D column. I compare this 0.257 with all other values available with the C column. I compare all the things, but nearest maximum is 0.25943 available in the C column. So that I put 4, the serial number in first. Okay, here 4. You can understand. I compare D with the C. D with the C means nearest maximum 0.257. The nearest value is 0.259. The corresponding serial number is 4, so that I generate 4. Not same. if I compare 0.8589, okay, 0.589 is the serial number to random number. I compare this value with all other random numbers available, I mean C values available with the column 3. Okay, here 0.589 where it was 0.4479 is the nearest value, so that I choose 7 as a E value. Likewise, I generate, compare and get the serial number values as a E value. After getting this, I go for next step. After reproduction, after I go for next step as a crossover. Here I reproduce the E value 4, 7, 3, 7, 10, 5, 7, 3, 7, 8 likewise. And also I call the substring corresponding substring value from fourth population. Here you see corresponding fourth corresponding fourth substring value from the initial population, that is 0 1 0 1 1 0 1 1 likewise I get. Okay, after reallocating the table, I may go for crossover function. For the reason I choose the random number in between 0 and 1 from the calculator. Already you are aware about how do we generate the random numbers with the aid of calculator. That is 10 random numbers because I have 10 populations. After the random number generation in between or less than zero point 0.8, because our crossover property is zero point 0.8. So less than or equal to zero point 0.8 only you should collect from calculator. More than zero point 0.8 means you leave that the random numbers. You choose only random numbers below the zero point 0.8 value, 0.7, 0.3, 0.7, 0.8, likewise I count. After that I will go for f. What is f? I may get the zero point 0.8 means yes, I do the reproduction function. If I get more than zero point 0.8 means I won't do the reproduction, then I put the no n value. Okay, if according to this generated random numbers, I got all the things with the less than zero point 0.8, so that I can perform reproduction for all the strings. Okay, here I can tell new word, that is pair. Pair means first serial number and the second serial number is the pair, and the 3 and 4 is another pair. 5 and 6 is the another pair. Likewise, I choose the pairs from available substrings with the mating pool. After that, I generate the random number in between 1 to 16. Why I go for 1 to 16 means I got 16 digits with the substring 1 and the substring 2. So that I choose the random number 1 to 16. So now first pair means serial number one and serial number two. First pair I got 7 as a random number. In theoretical part, I told you what how do we conduct a reproduction test. I may got 4, so that after 4 I may put a straight line. After fourth digit I may interchange all the things. Likewise here I got a random number, so 7, so that after 7 I put a straight line. After that 1 0 and the substring to all digits are available. So uh, I interchange all the things available with the after seventh digit. Likewise after here the year ahead. Okay, interchange the places. After that 13, so after 13 I put a straight line, interchange the things available with the substring 2. Similar to same, after that I may got 14, so that interchange the places. After that 7, so that I interchange the places of substring 1 to 2, 2 to 1. Likewise I interchange. Okay, after that 11, after 11 I may interchange the places. Okay, which is known as crossover. This step is crossover. After crossover, I rearrange all the things and goes with the mutation operation. Mutation operation is conducted with the mutation size, that which means how many populations I conduct, how many strings I conduct the population. Here, for identify the mutation size, I go with this formula, that is population size into bit length into mutation probability. In this problem, population size is 10, so that I put 10 into bit length. I consider 8 digits, so that 8 into mutation probability. According to this problem, I consider zero point 0.1 is the probability of mutation, so that 10 into 8 into zero point 0.1 is equal to 8. Here, I generate the random number 1 to 8 initially.
laterally you know about why I develop random number 1 to 8 and 1 to 6. I tell you why I select 1 to 8 means um, strings number of bits available with the substring is 8. Okay, I consider substring 1 and the substring 2. Total digits are available with the substring 1, the substring 2 is 16, so that random number 1 is follows 1 to 8. Second random number is uh, follows to 16. Okay, according to this problem, random number 1 6, the second is 9. Okay, so I choose sixth serial number. And I see the ninth digit is a zero. There I put a square. Okay, after getting this I convert that is zero within square box. I convert that zero it into one, which is the mutation process. After that, second random number is 3. So I consider third serial number from population. Then I get 9 as the random number. So the ninth digit, I consider ninth digit. Here, ninth place, I have 0, that I convert that 0 it into 1, which is the mutation process. After that, second. So that I select the second uh, serial number, second population. After that, I get 13. So that I choose 13th digit. Here, 13th digit, there is 1 is available. I convert that 1 it into 0. Okay. After that, finally 9. Okay. Ninth. So that ninth, I go for ninth population. In ninth population, I further got 7 as a random number. So I convert that random number 0 it into 1, okay, which is the mutation process. Here you see I develop 8 random numbers because mutation size is 8. So that I shall choose the 8 random numbers. The first 4 random numbers with lying within the 1 to 8, because substring value I consider 8 bits, so that 1 to 8. The second random number is lying in between 1 to 16, because the addition of substring 1 and 2, totally I have 16 digits, so that I choose uh, 1 to 16. Likewise, we conduct or change the 1 into 0, 0 it into 1. Likewise, I conduct the mutation test. Okay, after mutating, I go for real number generation. How do I convert the string? Okay, now I generate the I convert the digits with the reproduction crossover mutation. After that, I go for convert that crossover number, crossover binary number. I mean, mutated binary number it into real number. For the reason, I go for real number conversion from binary. Now also I go show you yeah example. How do I convert? Here again you press the mode function. I convert that into binary number B. After that, I type the digit values 0, 1, 0, 1, 1, 0, 1, 0. So after entering that number is equal to, after that I convert that into decimal number. There is 90. I got 90. Okay. So So the first real number is 90. Likewise, I conduct all the things with the real number 1 and the real number 2. I may get the new real number 1 and 2. According to this, I find the x1 and x2 through previous formula. x1 is equal to x1 min plus x1 max minus x1 min divided by 2 power l minus 1 into random number 1. Here, real number 1. Okay. Based on that, I may get 3.1765. Here also x1 min is equal to 0, x1 max is equal to 9, and also random number. Here random number, not a random number, real number, I got 90. Likewise, I substitute the value, I may get the x1 values for all the population 10 like this, and the x2 value the same formula uh, for x2. Likewise, I generate x2 all 10 values. Based on this, our objective function is 2x1 plus x2 power 4. Based on the identified x1 and x2 value, I may get f of x value for all the populations, which is the maximization problem. So that fitness function capital F is equal to f of x. So that all fitness function values is same as like f of x value. Okay, which is the fitness function. Okay, finally, we go for zeroth iteration. According to up to the previous slide, we may aware about how to conduct the manual calculation with the genetic algorithm. Now I convert that into iteration table. Okay, same the thing available. Serial number 1 to 10. Initially random number generated 10 numbers. Random number 2 I generated, and also I convert that random number it into a binary number. Likewise, substring 1 and the substring 2. And also I utilize the formula x1 and formula x1 is equal to x1 min plus x1 max minus x2 x1 max minus x I mean x1 is equal to x1 min plus x1 max minus x1 min divided by 2 power l minus 1 into random number. From that I may get the x1 value and the x2 value. Based on the x1 x2 I may got f of x value here, which is the maximization problem, so that capital F is equal to small f of x. Okay, here compare all the 10 populations. Okay, which one is maximally 150.7503. Okay, so that according to zeroth iteration, I got the maximum fitness function like 150.7503. The next step, A B. You aware about how do we identify the A value, B value, C value, D value. Likewise, how do we conduct the reproduction? After reproduction, how do we conduct the crossover? After crossover, how do we conduct the mutation? Likewise, you are aware. So that after mutation, we may convert the random number. Further again we can identify the x1 x2 value based on that identified x1 and x2 we may solve the f of x. Okay, from this maximization function f is equal to f of x, so that we may got the 10 f of fitness function values. From that I compare all the 10 values, I may get the maximum value from available population, that is 3574.807. Okay, so according to the zeroth iteration, 150.747, 14747 is the maximum value. So 50.747. First iteration maximum fitness function is 3574.807. So the maximum value occurs at the first iteration of f of x, the 3574. I compare the first zeroth iteration value and the first iteration value, so that maximum value is 3574.807 with the x1 value is 2.7529 and 7.7294. So these are all the x1 and x2 value. Final fitness function, the maximum fitness function is 3574.807. Likewise, we may get the best fitness function value through n number of iterations. We may continue the same steps for 100 iteration also. Okay, we may get the n number of solutions, that is global solutions. We may get the global solutions than local solutions. From that global solution, we may infer which x1 and x2 value is suitable for maximize the problem. Right? Likewise, we get the answer, which is genetic algorithm. Okay, thank you all. Have any doubt with this presentation? You may ask me in the presentation comment box. Thank you all. Thank you.